How would you read this decimal number, Irving? How about 0.25436? Not quite. How about you, Bruno? How would you properly read this decimal number? I have no idea, Mr. Cox. Okay. The first step in understanding decimal arithmetic is to be able to understand decimal numbers. Let me list the things we'll be covering in this video. First, we will learn how to properly read a decimal number, and we'll learn how to tell the decimal place value from the numerical part. Second, we will learn how to change decimal numbers into fraction numbers, and then learn how to change fraction numbers back into decimal numbers. We will then learn how to compare decimal numbers to each other. Now let's get started. Reading a decimal number is not that much different than reading a whole number. There are a few minor differences which I'll explain. Let's take this number again. Let me remove the decimal point for a moment and turn it into a whole number. Then ask you to read it, Irving. Well, that's easy. It's 25,463. That's correct. Whether you realize it or not, when you read that number, you also read each of the numerals' place values. Just by reading the number, you had to know the place value of each digit. Let me show you each numeral's place value. The 3 is occupying the 1's place. The 6 is occupying the 10's place. The 4 is occupying the 100's place. And the 5 is occupying the 1000's place. And the 2 is occupying the 10,000's place. Now, reading a decimal number is not that much different than reading a whole number. There is a few differences, and if you can read a whole number, you should be able to read a decimal number if you just remember those minor differences. When you read the place values in a regular whole number, you start from the right-hand side, and the place values start with the 1's place. When you read the place values in a decimal number, you start reading them from the left to the right with the first number after the decimal point, and there are two differences from whole numbers. The first place value has no 1's place. A decimal number starts at the 10's place with a th on the end to identify it from a 10's place in a whole number. All decimal place values have a th on the end to identify them as decimal place values, whereas without the th, that would mean whole number place values. Now let's read off all place values in this number starting with the 10's place. The second place value in a decimal number is the 100's place. The third place value in a decimal number is the 1000's place. The fourth place value in a decimal number is a 10,000's place. The fifth place value in a decimal number is a 100,000's place. As you can see, the place values increase like whole number place values except for three differences. 1. You start reading them from the left to the right instead of the right to the left. 2. They do not have a 1's place value. They start with the 10's place value, and they are the same as whole number place values except they have a th on the end of them to show that they are decimal place values and not whole number place values. So in this decimal number, what's the last place value, Bruno? 100,000s. Yes. Now let me show you how to properly read a decimal number. Unlike a regular number, with a decimal number you have to do two things. First, you have to determine the last place value of the number because you're going to have to know that after you read the number part. In this decimal number, the last place value is 100,000ths. Now how would you read the number itself, Irving? You mean a 25436? Yes, read it just as you would a regular number, ignoring the decimal point for a moment. Okay, 25,463. Now you speak the place value to identify it as a decimal number. If you were to stop there, everyone would think you're talking about a whole number. 100,000ths. Let me try this from the beginning. 25,463 100,000ths. Is that right? Yes, it is. Now let me change the number slightly to see if we can properly read it. I want you to read this number properly. The first thing you should do is to determine the place value here. What is the last place value here, Bruno? The first place is a 10's place. The second one is a 100's place. The third one is a 1000's place. And the last one is a 10,000's place. Correct. So our number is in a 10,000's place. Now read the number part and attach the place value onto it when you finish reading it. Okay, 2,546 10,000ths. Excellent. Again, let me change the number slightly. Irving, what's the last decimal place value in this number?
The first place value is tenths. Second place value is hundreds. The third and last place value is thousands. So the number's in thousands.
Yes, now read the number part, then attach the place value onto that when you're finished reading it.
So you read it as 254 thousandths.
That's right. Now let me change it again. Bruno, tell me what the last place value is in this decimal number, then read the number properly.
The first place value is tenths, and the next and last one is hundredths. In order to properly read this number, I have to read the numerals first, then read the last place value to it. It's 25 hundredths.
Correct. One more. Irving, tell me the place value in this number, then read it.
The only place value here is tenths. And to read that number properly is 2 tenths.
Very good. Now here are several more decimal numbers I'd like you to read. Remember to first figure out the decimal place value before you read the numerical part.
Okay, the first one is in the thousands place value, and the number part is 206, so it's 206 thousandths.
The next one's place value is 10 thousandths, and it's read as 105 10,000ths.
The third one is also 10 thousandths place, and you read it as 7 10,000ths.
The fourth one is in the thousands place, and it's 625 thousandths.
The next one is in the hundreds place, and it's read as 78 hundredths.
The last one is in the tens place, and it's read as 6 tenths. That was very good. Now here's a list of decimal place values up to 6 places. In order to know how to read decimal numbers properly, you must be able to remember these place values. 1 decimal place is tenths. 2 decimal places is hundredths. 3 decimal places is thousandths. 4 decimal places is 10,000ths. 5 decimal places is 100,000ths. 6 decimal places is millions. You will have to know this information when you're changing decimal numbers into fractions, so it's a good idea to memorize these place values. Now what about a number like this? It's not much different than reading a decimal number. First you read the whole number part, then you read the decimal point as the word and, then read the decimal number. Here the whole number is 3 and 15 hundredths. Irving, how would you read this number?
Well, the whole number part is 18. You read the decimal point as and the decimal place value there is thousandths. So I read it as 18 and 205 thousandths.
Good. How about this number, Bruno? It's read as 8 and 200 thousandths. Yes, one more number, Irving.
You read this number as 106 and 5 tenths.
Okay, now let's see if we can take a decimal number and write out its value in words.
What do you mean, Mr. C?
Let's take an example. Let me write this number in word form. First, I must write the numerical portion, which is 206. Then write the place value next, which is thousandths. Now let me write this number in word form. The numerical part is 78. The place value is hundreds. Bruno, can you write this number in word form?
I think I can. The numerical part is 625, and the place value part is thousandths. 625 thousandths.
That's correct. Irving, can you do this number?
I sure can. The numerical part is 105, and the place value is 10 thousandths. So it's 105 10 thousandths.
Excellent. What about this number, Bruno?
That's written as 53, which is the whole number part, and 25 hundredths, which is the decimal part. 53 and 25 hundredths.
In this section, we will study how to change fraction numbers into decimal numbers, then change decimal numbers back into fraction numbers. I'm going to assume that the viewer has learned fraction arithmetic because there are certain things you must know about fractions to be able to do some of the problems that we will introduce in this section. First, let's change some simple fraction numbers into decimal numbers. Let's take the first number on this chart. I want to ask you just what that object is.
Well, that's easy. It's a fraction.
How about you, Bruno? What would you say this is?
I have to agree with Irving. It's a fraction.
Okay, now let me ask you another question. What is this word?
Well, that's easy too. It's record. Wait a minute. Isn't that record? Now I'm confused.
That's because the word has more than one meaning. It could be the noun, record, or the verb, record. Now, the next time someone asks you what this word means, you should answer that you don't know because it has more than one meaning. Now let's go back to this number again. It actually has several meanings. We'll focus on two of them here. This could be the fraction 1/4, or it could also be read as a division problem, 1 divided by 4. If you read it as a fraction, here's how it's interpreted. If you've had fraction arithmetic, you should know that the bottom of the fraction always tells you how many equal pieces an object was cut into, and the top tells you how many of those pieces you're talking about. Here we're talking about one part out of a total of 4 parts. But if we want to change this number into another form, we have to do some work, and in math that usually means some arithmetic operation. And as long as this can also be read as a division problem, 1 divided by 4, we have our arithmetic operation. You write the division house alongside the bottom number, and picture tilting the fraction so that the top number slides off into the division house. So we're dividing 4 into 1. It's important to remember here that the top number of the fraction always goes into the division house, and the bottom number always goes on the outside. It will never be the other way around. Let me ask you another question before we go any further. How many ways can you write the number 3?
Is this a trick question, Mr. C?
No, not really. This is something all students should know. Any whole number can be written as a fraction simply by writing the number over 1, and any whole number can also be written as a decimal number simply by writing a decimal point behind the number and placing a 0 or zeros behind the decimal point. Now back to our division problem. When you're dividing a larger number into a smaller number, you'll have to write the number inside the division house as a decimal number and carry it out to several place values. We'll use 2 place values here. Once you've placed your decimal point in your problem, the next step is to place the decimal point in your answer directly above the decimal point in your problem and start doing regular division. 4 divides into 10 at most 2 times. Perform subtraction and bring down the 0 and divide again. 4 divides into 20 evenly 5 times with no remainder. So as you can see, we've just changed a fraction 1/4 into the decimal number 25 hundredths. Now how about the next fraction? Could you change 1/2 into a decimal number, Bruno?
I can try. I have to read this as a division problem, and here's how I do it. Write the division house alongside the bottom number and picture tilting the fraction so the top number slides off into the division house. So we're dividing 2 into 1. In order to divide a larger number into a smaller number, we have to write the smaller number as a decimal and place some zeros behind the decimal point. Next, we place a decimal point in our answer directly above the decimal point in our problem and perform regular division. 2 divides into 10 evenly 5 times with no remainder, so we don't have to go any further.
Correct. You've just written the fraction 1/2 as a decimal number 5/10. Now how would you write the next one, 3/4, as a decimal number, Irving? You write the division house alongside the bottom number and let the top number fall inside. Next, you write the 3 as a decimal number and place 2 zeros behind the decimal point. Place the decimal point in the answer directly above the decimal point in the problem and start dividing. 4 divides into 37 times with a remainder of 2. Bring down the 0 and 4 fits into 20 evenly 5 times. So the fraction 3/4 can be rewritten as the decimal number 75 hundredths. Now let's see if we can change those decimal numbers back into fraction numbers. Let me do the first one. How would you read this number properly, Bruno?
It's read as 25 hundredths.
Yes. Now let me show you how to change it back into fraction form. The numerical part always goes on top of the fraction, and the place value always goes in the bottom of the fraction like this. How would you write hundredths as a number, Irving?
I guess it's 100.
That's right. Since our decimal is in the hundredths place, we place a 100 in the denominator. Another way you could remember this is to write the number in the top of the fraction, then place a 1 in the bottom, and count your place values in your decimal number. Here we have 2 places, so we place 2 zeros in our denominator. One more step is that this fraction can be reduced top and bottom by the common number 25 to get 1/4. Irving, can you change a decimal number 5/10 into a fraction?
You write the number part in the top of the fraction, which is 5. The place value is in tenths, so 10 goes in the bottom of the fraction. If you ever forget decimal place values, you could also write a 1 in the bottom, and because tenths is one place value, you put 1 0 in the denominator of the fraction. One more step is that this fraction can be reduced by the common divisor 5, which reduces to 1/2.
Correct. 5/10 can be rewritten as a fraction 1/2. Bruno, can you change the last decimal number into a fraction? And make sure you reduce it to its lowest terms if it can be reduced.
Yes, you write the numerical part on top of the fraction, and since the place value is in hundredths, we write 100 in the denominator. In case we forget decimal place values, we can always write the numerical part in the numerator, then write a 1 in the denominator, and since the decimal has 2 places in it, we put 2 zeros behind the 1 and we still get 100. Next, since 75 and 100 have a common divisor 25, the fraction can be reduced to 3/4.
That's correct. 75 hundredths can be rewritten as a fraction 3/4. Now I should tell you that not all fraction numbers divide evenly with no remainders. Some fractions will divide endlessly without ever stopping. There are 2 ways you can handle this, and let me show you both ways. Each one has its advantages and disadvantages, so you'll have to decide on which one you're going to use depending on your problem. When you change 1/3 into a decimal, you know you have to write the numerator inside the division house and the denominator outside. Then you place your decimal points, write some zeros, and start dividing. 3 divides into 10 3 times with a remainder of 1. Bring down your next 0, and 3 divides into 10 again 3 times with a remainder of 1. If we keep dividing, we're going to keep getting a remainder of 1, so we'll stop after 2 places, and here's how we write the remainder. We take it and write it as a fraction 1 over the divisor 3, or 1/3. This number may look a little strange, and you may not be sure how to read it. It's read as 33 and 1/3 hundredths. It's a little bit larger than 33 hundredths, but not as large as 34 hundredths. You don't normally use this form of a decimal number. Instead, you would round it off, as in this example. Here you'd first determine at what place value you're going to round off your answer, and you carry out your division one more place than where you want to round off your number. Let's take a moment and look at the concept of rounding off decimal numbers before we continue with this problem. Let's say I want to round off 3,546 10,000ths to the thousands place. Here's how we do that. We have to locate the thousands place value, since that is the last digit we're going to keep, and we're going to get rid of all the place values past that number. The rule is that we have to look at the number to the right of the 4 to determine if we're going to raise up the 4 by 1 or keep it the same. The rule is that if the number to the right of the place value you're going to round off is less than 5, you just drop the rest of the numbers and keep the 4 exactly the same. If the number next to the 4 is 5 or larger, you round up the 4 by 1. Since 6 is bigger than 5, we have to round the 4 up by 1 to make it 5, then drop the rest of the numbers off past the 5. So when we round off our original number to the thousands place, it becomes 355 thousandths. What if I wanted to round off the original number to the hundreds place instead? Could you do that, Irving?
Okay, 5 is in the hundreds place, and that's the last place value I'm going to keep. I have to look at the number just to the right of it to see if I'm going to leave the 5 as it is or round it up by 1. That number is smaller than 5, so I leave the 5 alone and drop off the rest of the numbers. So the number rounded off to the hundreds place is 35 hundredths.
Yes. Bruno, how would you round off the original number to the tenths place?
The 3 is in the tenths place. I'm going to have to look at the number next to the 3 to see if I'm going to leave it 3 or round it up by 1. Since that number is 5, I have to round up the 3 to 4 and drop off the rest of the numbers. So this number rounded to the tenths place is 4 tenths.
Excellent. That would be how you round off our original number to tenths. Okay, let's look at the next number. 9,162 10,000ths. Let's do this one starting from tenths first. Irving, can you round this number off to the tenths place?
9 is in the tenths place, so I'm going to drop off all the numbers after 9. I have to check the number next to the 9 to see if I raise it up by 1 or leave it the way it is. Since it's 1 and 1 is less than 5, it remains 9, so it rounds to 9 tenths.
Very good. Bruno, can you round off the original number to the hundreds place?
Okay, the 1 is in the hundreds place, so I have to look at the number to the right of it, and it's bigger than 5, so I have to round up the 1 to 2 and drop off the rest of the numbers. So the original number rounds to 92 hundredths.
Irving, can you round off the original number to the thousands place?
Yep, the 6 is in the thousands place, and the number next to it is smaller than 5, so I just drop the last digit and keep the 6 the same. So that number rounded off to the thousands place is 916 thousandths.
Very good. Now let's look at one more example to make sure we know how to round off decimal numbers. This number is read as 70,504 hundred thousandths. First, let's round this number off to the 10,000ths place. Locate the 10,000ths place, which is where the 0 is. Now look to the number to the right of the 0, and it's less than 5. So we just drop the number off and keep the 0. Normally, if your last number is a 0, you drop that off too. But since we're instructed to round off to the 10,000ths place, we have to keep this 0 in order to hold the place value. We'll go into further detail on this when we study the rules of addition, subtraction, multiplication, and division of decimal numbers. But for right now, we'll keep the last 0, and the original number rounded off to the 10,000ths place is now 7,050 10,000ths. Irving, can you round off the original number to the thousands place?
Yes, the 5 is occupying the thousands place, and the number to the right of it is less than 5, so I just keep the 5 the way it is and drop off the 0. It's now 7,005 thousandths.
Bruno, can you round off the original number to the hundreds place?
I can. The 0 is in the hundreds place, and the number just to the right of it is 5, so I have to round up the 0 by 1, then drop the rest of the numbers off. So this number rounds to 71 hundredths.
One more. Irving, can you round off the original number to the tenths place?
The 7 is in the tens place, and the number just to the right of it is 0, which is less than 5. So I keep the 7 as it is and drop off the rest of the digits, and it rounds off to 7/10.
Let's go back to our problem where we were changing fractions to decimal numbers. You remember that we could write our answer two different ways for this division problem. One was to write any remainder as a fraction in the answer. The other way was to round off the answer to a specific decimal place value. Here I wanted to round off my number to the hundreds place, and you know that hundreds has two place values. You will always divide out one extra place from where you want the number to end in order to see if the number in the place value is going to remain the same or be raised up by 1. After dividing the three places, we look at the third place. That number is less than 5, so we just drop the final number off and leave our hundreds place number as it is. So as you can see, we have two different ways in which we can carry out the division. Most of the time you'll use this form, but this form is exact. Using this form, you can always change it back to its original form 1/3. But since we rounded the second one off, it's no longer exact, and you can never get back to the original fraction 1/3 if you wanted to change the decimal number back to its fraction form. Let's change the second fraction, 5/6, to a decimal. We'll do this fraction two ways also, one with a fraction remainder, and the other way where we round it off to the hundreds place. In the first problem, we divide out to two places and we wind up with a remainder of 2. We write that remainder over our divisor, 6, to get the fraction 2/6. We can reduce the fraction to 1/3. So the fraction 5/6 can be rewritten as a decimal number 83 1/3 hundredths. Now if we want to write it as a rounded off decimal number and want to round it off to hundreds, we have to carry it one place further than the hundredths place to be able to round it off when we finish dividing. After doing the division, we see that the number just past the hundredths place is 3. So what does our number round off to, Irving?
Since 3 is smaller than 5, it means that we keep the 3 in the hundredths place as it is and just drop off the last digit. So the fraction 5/6 can also be rewritten as a rounded off decimal number, 83 hundredths.
Let me point out here that you can carry out your division to any place value you want to. You can round off the decimal number to tenths, hundredths, thousandths, or more place values. I chose hundredths because it's a common place value to round off decimal numbers to. Now what about 2/3, Bruno? Can you do the first division problem here?
Yes, I can. After dividing the two places, we get a remainder of 2, and we write that as the fraction 2/3. So the fraction 2/3 can be rewritten as a decimal number 66 2/3 hundredths.
Irving, can you write this fraction number rounded off to two decimal places?
I sure can. Because hundredths has two place values in it, we have to divide out the three places and look at the number in the third place to see how we're going to round off that decimal. After dividing out the three places, we wind up with a 6, which is greater than 5, so we have to round off the second 6 up by 1 to 7. So our fraction 2/3 rounds off to the decimal number 67 hundredths.
Very good. Now let's change some mixed fraction numbers into decimal numbers. Let me do the first one, 5 4/7. The only part here that we have to change is the fraction part. The whole number stays the same. I'm going to show the fraction rounded off to two places, or the hundredths place, since this is the form that's most commonly used. After performing the division to three places, I get a 1 in the last place, which is less than 5, so our rounded off number is 57 hundredths. So 5 4/7 can be rewritten as the rounded off decimal number 5 57 hundredths. Irving, can you change the mixed fraction 16 1/40 into a decimal number?
Yep, the whole number remains 16, and we have to perform division on the fraction to change it to a decimal. After dividing 40 into 1 out to three places, the last number is 5, so that means I have to round up the number in the hundredths place by 1 to 3. So the mixed fraction can be changed into the mixed decimal number 16 3 hundredths.
Bruno, can you change the last mixed fraction number into a mixed decimal number?
I think I can. After dividing 25 into 1, it goes evenly after 2 places, so we don't have to worry about going any further. It automatically stops in the hundreds place. So 8 and 1/25 can be rewritten as the mixed decimal number 8 and 4 hundredths.
You both did very well. Now let's change some mixed decimals before we move on to the next section. First, how do you read this number, Bruno?
It's 4 and 6 hundredths.
Now write it as a fraction.
The whole number 4 remains the same, and we rewrite the decimal part. The number here is 6, and it goes in the top of the fraction. The place value is hundredths, so 100 goes into the bottom of the fraction. 6 hundredths can be reduced top and bottom by the common number 2 to get the reduced fraction 3/50ths. So 4 and 6 hundredths can be rewritten as the mixed fraction 4 and 3/50ths.
Yes. Irving, can you rewrite the second mixed decimal to a mixed fraction?
The whole number, 9, stays the same. The decimal number rewrites to 5 on the top of the fraction, and the place value is in thousandths, so the number 1000 goes into the bottom. The fraction part can be reduced by 5, which reduces to 1/200th. So that number can be rewritten to 9 and 1/200ths.
Bruno, take the last number and rewrite it.
First of all, the number can be read as 12 and 75 10,000ths. The whole number 12 stays as it is, and the decimal part rewrites to 75 on the top, and since the place value here is 10,000, the number 10,000 goes into the bottom. The top and bottom of the fraction can be reduced by the common number 25 to get the reduced fraction 3/400ths. So the mixed decimal number 12 and 75 10,000ths can be rewritten as the mixed fraction number 12 and 3/400ths.
Now that we know how to change fractions to decimals and decimals to fractions, let's move on to comparing numbers to each other. There are 3 ways 2 numbers can be related to each other. They can be equal to each other, one can be larger than the other, or one can be smaller than the other, depending on the order in which you read them. When comparing 2 numbers to each other, we use symbols instead of words because it's easier to write symbols. The problem most people have is remembering what the specific symbol means. Let's see if we can figure out an easy way to remember the definition of these symbols. If we want to compare these 2 numbers to each other, we read it as 6 equals 6. If we want to compare these 2 numbers to each other in the order that you see them written, it's 6 is greater than 2, or 6 is larger than 2, or 6 is bigger than 2. If we want to read these 2 numbers compared to each other in the order that they are written, it's 2 is less than 6, or 2 is smaller than 6. It's pretty simple to read these numbers if you use words to compare them to each other. But let's see if we can use symbols instead of words.
It's using those symbols where I get confused, Mr. C.
Okay, for the top numbers, everyone should know that this is the sign for equal. In the second set of numbers, this is a sign for greater than. And it's obvious that the first number here is larger than the second number. We always read left to right, and if you do that, you will always be able to place the proper sign between the 2 numbers. In the bottom set of numbers, this is the sign for less than. And here too, it should be obvious that the first number is smaller than the second number when you read left to right. Now let me explain how you can always remember which sign to use. Here is an easy way to remember the definition of the 2 different ways an arrowhead can point if you forget. In the first set of numbers, you'll notice that the larger number is first and the smaller number is second, and the tip of the arrow always points to the smaller number. In the second set of numbers, the smaller number is first, and again, the tip of the arrow is still always going to point to the smaller number. If you look at the arrowhead, it has a small tip and an open, larger end. The open, or larger part of the arrowhead always goes with the larger number. and the tip of the arrow always points to the smaller number. If you can remember this fact, you will always know which way to point the arrowhead between any two numbers. Just write two numbers down next to each other and put the words between them in regards to their relationship with each other. Let's see if we can properly place the arrowhead between these two numbers and see if we can then remember its definition. Irving, can you place the arrowhead between these two numbers and tell me in words what it means?
Yep, I sure can. I read this as 7 is greater or larger than 4. I know that the tip of the arrowhead, or smaller end, points to the smaller number, and the open, or larger end, points to the larger number like this. So I know that when the arrow points to the right, it means greater or larger than.
Bruno, can you place the proper symbol between these two numbers?
Yes, I know that reading from left to right, that 21 is smaller than 36. The tip of the arrowhead points to the 21 because that's a smaller number, and I read that as 21 is less than or smaller than 36.
Okay, let me ask you a question before we move on. What if you forget the definition of greater than or less than? What could you do to remember them?
Let me give this a shot. If I wasn't sure, all I'd have to do is write two numbers side by side, then read them left to right. I can pick any number I want for the first one, like 5. Then I can pick any number for the second one, like 3. Next, all I have to do is remember to place the arrowhead with the tip, or smaller end, towards a smaller number, and the open end, or larger side, towards a larger number. Now all I have to do is read the order of the numbers left to right. 5 is obviously larger than 3, so when the arrowhead is pointing to the right, it means greater than or larger than. If I wrote those two numbers in the other order, 3 first then 5, I would flip the arrowhead to point the other way, and it reads 3 is less than or smaller than 5. So when the arrowhead points to the left, it means less than or smaller than.
That's correct. If you ever forget the definition of the two ways the arrowhead is pointing, just write two numbers alongside each other, and the only part you have to remember is the arrow tip points to the smaller number and the open end points to the larger number. Then all you have to do is read the relationship of the numbers to each other from left to right. Okay, now let's use this information to compare decimal numbers to each other. But first we have to review a little about fractions, since we're going to have to change the decimal numbers to fractions before we can compare them to each other. When you learned fraction arithmetic, you should have learned how to compare fractions to each other. If you wanted to compare these two fractions to each other to see which is larger, you had to do certain things to them first. Is 5/8 less than 7/12, or is 5/8 larger than 7/12? The way to find out is that you have to find the lowest common denominator for both fractions, then raise them both up to that lowest common denominator. Then you can compare them. Here the lowest common denominator for 8 and 12 is 24. 5/8 can be raised to 15/24, and 7/12 can be raised to 14/24. Now you just look at the tops to see which one is bigger and which one is smaller. 15 is larger than 14. So our original fraction, 5/8, is larger and 7/12 is smaller. Now what if we want to compare decimal numbers to each other, like these two numbers, to see which is larger and which is smaller? So I can then place the proper sign between them.
I'm not quite sure how to do that.
Me either, Mr. Cox. Okay, here's what I would suggest. First, we have to write these as fraction numbers, and you know how to do that now.
Yes, the first number is read as 6/10, and it's written as a fraction 6/10. The second number is read as 4/10, and it's written as a fraction 4/10.
Now, since we have them in fraction form, and the denominators are the same, all we have to do is compare the tops of the raised fractions to see which is larger and which is smaller. 6 is larger than 4, which means that the decimal number 6/10 is larger than 4/10. So which symbol do we use here, Irving?
Since 6/10 is a larger number, the open end of the arrowhead points to it, so the tip of the arrow points to the right.
That's right. Now what if I wanted to compare these two numbers to each other to see which is larger? We have a problem here because the first number is in hundreds, and it will have 100 in the bottom of the fraction, and the second one is in thousands, and we'll have a 1,000 in the bottom, and we can't compare fractions unless the bottoms are the same. But before we rewrite these as fractions, can you guess which is larger? It looks like 237 thousandths is larger.
I'll agree with that.
Okay, let's see if we can figure out a way to compare these two numbers to see which is larger. First, we look at the number or numbers with the largest place value and add zeros to the rest of the numbers to make them all have the same amount of place values. Here the largest place value is 3, so in the first number we have to add a 0 to it, so it has 3 places in it also. Now we have both numbers in thousands, so we can now rewrite them as fractions. The first one is 270 over 1,000, and the second one is 237 over 1,000. Now all we have to do is compare the tops to see which number is larger. Which is larger, Bruno?
270 is larger than 237. So the original decimal, 27 hundredths, is larger than 237 thousandths.
Yes. You'll notice here that I left the original numbers unchanged at the top so that I could go back to them when I finished figuring out which one was larger. It's always a good idea to write your changes under your original numbers so that you'll always be able to refer back to the originals. What if I asked you to tell me which of these two numbers is larger? 3/8 or 41 hundredths? Could you do that?
Well, it would be nice if they were both fraction numbers or decimal numbers so we can compare them to each other.
Yes. Since this video is about decimals, change the fraction to a decimal, then do the problem.
Okay, I have to divide 3 into 8, and when I do, I get 375 thousandths. Next, because the largest place value here is 3, I have to add a 0 to the 41 hundredths so that it too has 3 place values. Next, if I write them as fractions, 375 over 1,000 is less than 410 over 1,000. So the fraction 3/8 is less than the decimal number 41 hundredths. So the tip of the arrow points to the fraction number because it's smaller.
Okay, one more. Bruno, can you tell me which of these two numbers is larger? 3/25 or 12 hundredths?
First I have to change the fraction 3/25 to a decimal by dividing 25 into 3. The answer to that division is 12 hundredths. So it seems that those two numbers are equal to each other.
What if I ask you to line these numbers up from smallest to largest? Could you do that?
Let me give this a try. I have to rewrite the fraction 3/4 as a decimal first. When I divide 4 into 3, I get 75 hundredths. Next, because the largest place value here is the second number with 3 places in it, I'm going to have to write the other two numbers as 3 places by placing a 0 at the end of them.
You could go one step further and write all of these decimals as fractions, but that's not really necessary. I just did that last step in the last example to make it clear. If you just ignore the decimal points for a moment and read the numbers, that will tell you which is the smallest, the middle, and the largest number.
Okay, I can finish that now. 734 is the smallest number, so we write that one first. 750 is the second largest number, so we write that number second. And the original number was the fraction 3/4. And 760 is the largest, and the original number there was 7,600, so we write that one last.
Now let's move on to the arithmetic of decimal numbers. Addition, subtraction, multiplication, and division. Before we start, I want to make a point about whole numbers and decimal numbers. Any whole number can be written as a decimal number by placing a decimal point at the end of the whole number and adding a 0 or a number of zeros after the decimal point. You can place as many zeros after the decimal point as you want to. Now let's talk about the rules of addition and subtraction of decimal numbers. We'll talk about addition first. We have to line these decimal numbers up so that the decimal points are in line, then place the decimal point in our answer in line with the decimal points in our problem. Next, you simply add the numbers as you would in any regular addition problem. You can add zeros to fill in the empty places in your decimal numbers if you want to make it easier to keep your columns straight. The first column adds to 2, the second column adds to 6, and the third column adds to 9. So when you add these three numbers together, you get 962 thousandths. Now how would you add these three numbers together, Irving?
First I have to write the whole number 17 as a decimal number. Then I line up the decimal points in order to keep everything straight. I can add zeros to fill in the places to make sure everything is lined up right. I put my decimal point in my answer in line with my decimal points in my problem, then add all the columns. The answer is 26 and 313 thousandths.
Bruno, can you add these two numbers together? 65 ten thousandths and 2 25ths?
I have to change a fraction into a decimal by dividing 25 into 2, which equals the decimal number 8 hundredths. Next, I line up the decimal points and place a decimal point in my answer in line with the decimal points in the problem, and add the columns together, which equals 865 ten thousandths.
Irving, can you add these numbers? 7 3/4 and 3 25 hundredths?
Before I can add them, I have to change the fraction in the mixed fraction number to a decimal. 3/4 can be changed to the decimal number 75 hundredths. Next, I line up the decimal points and place a decimal point in my answer in line with the decimal points in my problem, then add the columns together. They add to 11 and no decimal parts, so I guess the answer is just 11.
That's correct. Now that you understand decimal addition, let's see if we can solve some addition word problems. Ashley has to ship 3 packages together. The first package weighs 4 36 pounds. The second package weighs 2 74 pounds. And the third package weighs 7 67 pounds. What is the total weight of all 3 packages? And round off your answer to the nearest tenth. Now how would you solve this problem, Bruno?
Well, we have to find a total weight, which means we have to add everything together. Then round off the answer to the tenths place. When I add 4 36 hundredths, 2 74 hundredths, and 7 67 hundredths, I get 14 77 hundredths. The tenths place is the first decimal place, and the number next to that place is greater than 5, so you have to raise the 7 up by 1 to 8 and drop off the last number. So the answer rounded off to the tenths place is 14 8/10.
Well done. Irving, can you solve this problem? Ronald had to order a steel plate for a machine in his factory. The plate had to cover 4 lengths added together. One factory worker took 2 of the measurements one day, and another factory worker took the other 2 measurements on another day. The first 2 were 2 45 hundredths inches and 2 93 hundredths inches. The other 2 measurements were 1 7/8 inches and 2 1/5 inches. How big does a plate have to be to cover the 4 measurements? Round your answer to the tenths place. Now let me ask you a question before we go any further. How do you know when you're supposed to change the numbers to all decimal numbers or all fraction numbers? Because you can do this problem either way, as all fractions or all decimals.
I'm not sure about that, Mr. C.
Let me point out a few things that can help you decide which forms to use. If you're doing a problem and it has multiple choice answers like this, which form would you change them all to?
Well, those are all fractions, so I guess I'd have to change everything in my problem to fractions first.
Yes, if all of your answer choices are in fraction form, then you should change all of the numbers in your problem to fraction form. What if these were your answer choices? Which form would you use then, Bruno?
Those are all decimal numbers, so I guess I'd have to make the numbers in the problem all decimals in order to match one of those answers.
That's right. Okay, one of these choices is the answer to our problem. What are you going to do, Irving, to solve this problem?
I have to add all 4 measurements together to find out how big the plate has to be in order to cover the 4 pieces. I'm going to change the 2 fraction numbers to decimals
Then add them all together. The answer is 9 and 455 thousandths. The problem said I have to round off the answer to the tens place, so I have to look at the number next to the 4. It's 5, so I have to round the 4 up by 1 to 5 and drop off the rest of the numbers. The answer is 9 and 5/10.
Correct. So the plate has to be at least 9 and 5/10 inches to cover the 4 sections. Suppose you weren't paying attention to your answer choices, and you did the problem as decimals, and these were your answer choices. You should now be able to change the decimal part, 455 thousandths, into the fraction 455 over 1,000, then reducing this fraction by 5 to get 91 over 200. And you should also be able to change this fraction, 91 over 200, into decimal form by dividing 200 into 91 to get 455 thousandths if you had to. Now let's look at decimal subtraction. The rules for subtraction are just like the rules for addition. The only difference is that you're subtracting one number from another number. First, you line up the decimal points, then place the decimal point in your answer in line with the decimal points in your problem and subtract. 5 from 5 is 0, and 2 from 7 is 5. You know that from comparing decimal numbers that you can add zeros to a number without changing its value. You can also drop any zeros at the end of decimal numbers after you've finished doing the arithmetic operation. Here we have a 0 at the end of this decimal number, and we can drop it without changing the value of the number. Okay, how would you do this problem, Bruno? 6/10 minus 4/100. I have to line up the decimal points in the numbers, then place the decimal point in my answer. I'm not sure what to do next, though. In this problem, we're going to have to place a 0 in the top number in order to perform this arithmetic. Can you finish it now, Bruno? Yes, I have to borrow 1 from the 6 and add it to the 0 to make it 10. Then I can subtract 4 from 10 to get 6, and nothing from 5 leaves 5. The answer is 56 hundredths. Here's one for you, Irving. Subtract 59 thousandths from 20.
I have to write the 20 as a decimal number like this, then line up the decimal points in the numbers. I have to add 2 more zeros here to be able to do this arithmetic. I have to borrow all the way from the 2 and continue borrowing all the way over back to the last 0 before I can subtract. When you subtract 59 thousandths from 20, you get 19 and 941 thousandths.
Well done. You should also know how to do this problem too. Subtract 3/5 from 9/10. Remember, you could change the decimal 9/10 to the fraction 9/10 and do this as a fraction problem, but change a fraction 3/5 to a decimal and do the problem as a decimal problem.
I have to divide 5 into 3, and I get the decimal number 6/10. Next, I have to line up the numbers so that the decimal points are lined up. Then place the decimal point in my answer, then subtract. 6 from 9 is 3, so the answer is 3/10.
Correct. One more subtraction problem, then we'll do several word problems to make sure we understand decimal subtraction. What is 6 and 4/5 minus 2 and 7 thousandths equal to, Bruno? Okay, in order to change 4/5 to a decimal, I have to divide 5 into 4 and I get the decimal 8/10. Then you have to line up the decimal points in the numbers, then place a decimal point in my answer. Next, I have to add 2 zeros in order to be able to subtract. I have to borrow from the 8 all the way to the last 0. The answer is 4 and 793 thousandths. Now for a few word problems. Brandon has a wooden plank that's 6 and 35 hundredths inches long. He has to cut it so that it's 5 and 85 hundredths inches long. How much does he have to cut from the plank to get the piece he needs? Irving?
We have to subtract the piece he needs from the larger piece to find out how much he has to cut off. After subtracting 5 and 85 hundredths from 6 and 35 hundredths, I get 50 hundredths, which is the same as 5/10. He has to cut 5/10 from the board to get the piece he needs.
And you should know by now that the decimal 5/10 can be rewritten as the fraction 5 over 10, which reduces to 1/2. So he could also cut 1/2 inch from the board, which would be the same. Here's a problem for you, Bruno. Before going on a diet, Vicky weighed herself on a digital scale. Her weight before the diet was 141 4/10 pounds. After 1 month on a diet, she weighed herself again on a scale that measures in 1/4 pound increments.
Her weight on that scale was 133 3/4 pounds. How much weight did she lose in that 1 month period? And round your answer off to the nearest tenth. I have to subtract what she weighs now from what she weighed a month ago, which is 133 3/4 from 141 4/10. I have to change the fraction 3/4 to the decimal number 75/100 by dividing 4 into 3. Next, I have to add a 0, then subtract. I have to round off 65 thousandths to the tens place. The number next to the 6 is a 5, so I have to round up the 6 by 1 to 7. Vicky lost 7 7/10 pounds in 1 month. One more word problem before we move on to multiplication. The rainfall for Chicago 1 June was 3 75/100 inches. In July of the same year, it was 5 7/7 inches. Haley had to figure out how much more it rained in July than June and round off her answer to the hundredths place. How much was the difference? Irving, can you solve this one?
Yep, you bet I can. It's just a simple subtraction problem. I have to subtract 3 75/100 from 5 7/7 to find the difference. After borrowing and subtracting, I get 1 932 thousandths. One more step is that I have to round off the number to the hundredths place. The 3 is in the hundredths place, and the number next to it is smaller than 5, so the 3 stays as it is. The answer then rounds off to 1 93 hundredths.
Now that we understand addition and subtraction of decimal numbers, let's move on to multiplication. Let me multiply all 3 of these examples out to show you the rules of multiplication of decimals. There are several ways in which you can multiply 2 numbers together. Either one of the numbers can be a decimal number, or both of them can be decimal numbers. Here are 3 possible ways a multiplication problem could occur. First, we could have the whole number 24 multiplied by the decimal number 7/10. Or we could have the decimal number 24 hundredths multiplied by the whole number 7. Or they could both be decimal numbers, 24 hundredths times 7/10. You'll notice that the only difference between these 3 problems is where the decimal points are located. The number parts are all the same. Let me multiply all 3 of these out in order to show you the rules of decimal multiplication. The rule is very simple. You ignore the decimal points for a moment and perform regular multiplication first. In the first problem, 7 times 24 is 168. Now you have to place your decimal point in your answer, and here's how you do that. First, you count all the decimal places in your problem, and here we only have 1 decimal number with 1 decimal place, so we start from the right-hand side of our answer and count 1 place into the left. That's where we place our decimal point. So the answer to this multiplication problem is 16 8/10. Bruno, can you do the second example?
I'll try. I have to multiply 7 times 24, and I get 168. Next, I have to count all the decimal places in my problem in order to find out how many places I have to count to place my decimal in my answer. I only have 1 decimal number in my problem with 2 places in it, so I place my decimal point in 2 places from the right in my answer. The answer is 1 68 hundredths.
Very good. Irving, can you do the third example?
Okay, I ignore the decimal points for a moment and just do regular multiplication. 7 times 24 is 168. Now I have to count all the decimal place values in my problem. The first number has 2 place values in it, and the second number has 1 place value in it, which is a total of 3 place values. I have to place my decimal point into my answer 3 places from the right. That makes the answer 168 thousandths.
Very good. Again, the only difference in these 3 problems is where the decimal points are in the problems and in the answers. Now let me change the problem a little bit. What if I had to multiply 24 thousandths times 7/10? 24 times 7 is still 168, only now we have 4 decimal places altogether in our problem. 3 places in the top number and 1 place in the bottom number to make a total of 4 places. We only have 3 places in our answer, so we have to add a 0 to our answer to make 4 places. When we have to add a 0 in a multiplication problem in order to fill place values, it's important to place the 0 in the front of our answer, not behind as we did in the other problems. When we add the 0 to the front of our number, we then have 4 places so we can then place our decimal point. The answer then is 168 ten-thousandths. Now what if I had to multiply these two numbers together? Again, 24 times 7 is still 168. Only now we have 3 decimal places in the top number plus 2 decimal places in the bottom number for a total of 5 decimal places. In order to have 5 place values in our answer, we're going to have to add 2 zeros. We have to add 2 zeros to the front of our number, then place our decimal point 5 places in. When you multiply 24 thousandths times 7 hundredths, the answer is 168 hundred-thousandths. Now how would you do this problem, Bruno? 9 tenths times 16 hundredths.
I could do this 2 different ways. I could change the decimal 16 hundredths to the fraction 16 over 100 and do this as a fraction problem, but I suppose I should change the fraction 9 tenths to the decimal 9 tenths by dividing 10 into 9 and do it as a decimal problem. Next, I multiply 9 tenths times 16 hundredths and I get the number 144. I now have to place my decimal point in my answer. I have a total of 3 decimal place values in my problem, and I have 3 places in my answer. So all I have to do is place the decimal point over 3 places from the right. The answer is 144 thousandths.
Excellent. One more multiplication problem. Suppose I want to multiply these 2 mixed decimal numbers together. 2 and 2 thousandths times 6 and 34 thousandths. Could you do that, Irving?
Those are some pretty big numbers. Let me see. When I multiply 2 and 2 thousandths times 6 and 34 thousandths, I get 12,080,068. I have 6 decimal places in my problem, so I have to place my decimal point in my answer 6 places in from the right.
Okay, can you read that number?
Okay, it's 12 and 80,068 millionths.
Correct. Now let's see if we can take what we've learned so far and do some multiplication word problems. Richard had to buy propane for his barbecue grill. The propane cost $3.35 per gallon, and he purchased 4 8/10 gallons. How much did Richard pay for his propane? Bruno?
I have to multiply 3 35 hundredths times 4 8/10 to find out how much 4 8/10 gallons would cost. When I do that multiplication, I get this number.
Now where do you place your decimal point in your answer?
I have a total of 3 decimal place values in my problem, so I have to place my decimal point in 3 places from the right. It winds up between the 6 and the 0.
Now let me explain a few things about this answer. You'll notice the 0 at the end of this number. I had to keep that 0 in order to place my decimal point. Once the decimal point is placed, I can then drop the 0 at the end of the number. It's important to remember to keep any zeros at the end of your multiplication problems until you place your decimal point. Then you can drop any zeros from the end of the number. And besides, this answer is money, and money has 2 decimal places in it. Remember, we were looking for the cost of the propane, which was in dollars and cents. So 4 8/10 gallons of propane cost $16.08. Here's another word problem. Lily has to make a dress, and she needs 3½ yards of fabric. The fabric costs $1.29 per yard. How much would she have to pay for the fabric? Round your answer to the nearest cent. Irving?
I have to multiply 3½ times $1.29, which is the same as the decimal number 1 29 hundredths. I have to change the fraction 1/2 to the decimal number 5/10 by dividing 2 into 1, so that my numbers are all in the same form. Next, multiplying the numbers out, I get this answer. Now I have to place my decimal point in my answer. I have 3 decimal places in my problem, so I have to place my decimal point in 3 places from the right. One more step is that I have to round off the answer to the hundredths place because this is money. The 1 is in the hundredths place, and the number to the right of it is 5, so I have to round the 1 up to 2. So 3½ yards of fabric will cost Lily $4.52.
Here's one more question on this problem. The state where Lily lives has a 7% sales tax. What is her total cost including sales tax? Let me tell you that 7% can be rewritten as a decimal number, 7 hundredths. When you study percent arithmetic, you should learn how to change percents to decimal numbers. Bruno, how much will she have to pay including sales tax?
I have to find 7 hundredths of 4 52 hundredths, which means I have to multiply 7 hundredths times 4 52 hundredths, then add that answer back to the 4 52 hundredths to find the total. Here's the answer I get. I have to place my decimal point in 4 places from the right to get this decimal number. This is money, so I have to round it off to 2 place values. The number next to the hundreds place is larger than 5, so I have to round the 1 up to 2. So the tax is 32 cents, which I have to add to the $4.52. Lily had to pay a total of $4.84, including tax, to buy the fabric.
Very good. Now let's move on to the final arithmetic operation of decimals, division. Now let's look at the arithmetic of division for decimal numbers. There are 3 different ways in which a decimal division problem can appear. The first is when you're dividing a decimal number by a whole number. The second is when you're dividing a whole number by a decimal number. And the third is when you're dividing a decimal number by another decimal number. Now let me show you the rules for all 3 ways. Then we'll look at examples of each one to make sure we understand them. When you have this type of a situation, you first place your decimal point in your answer directly above the decimal point in your problem, then perform regular division. It's just the opposite of multiplication where you first did the arithmetic, then you place your decimal point when you were finished. In division, you have to place your decimal point first, then you divide. You remember in regular division, you have to figure out how many times your divisor will fit into the first set of numbers inside the division house. 5 fits into 45 exactly 9 times with no remainder. Bring down the next number, and 5 fits into 5 exactly 1 time. So 5 divides into 4 and 55 hundredths exactly 91 hundredths of a time. Or 4 and 55 hundredths divided by 5 equals 91 hundredths. Okay, now for the second example. We have a small problem in this example. What we're trying to do here is to divide 5/10 into 455. You know that in division that you have to make a first guess as to how many times this number will fit into this number. Can either of you make a guess as to how many times 5/10 will fit into 4?
Not me.
Me neither. Okay, here's what we do in this kind of situation. We have to momentarily rewrite the problem so that we can easily perform the division. What we want to do is to get rid of the decimal number in our divisor to make our division easier. If we just move the decimal point over 1 place, that would turn it into the whole number 5. And we know how to divide with whole numbers. Now here's the rule you have to remember. If you have to move a decimal point in the divisor, you must move the decimal point inside the division house by the same number of places. Here we moved it over 1 place, so we have to move it over 1 place here. You know that every whole number has a decimal point in it. It's at the end of the whole number. Now we have to add a 0 here in order to move the decimal point over 1 place. Here's what we wind up with. 5 divided into 4,550. You know how to perform this division, don't you, Irving?
That's easy. 5 divides into 45 9 times. 5 divides into 5 1 time. I have to place a 0 in my answer to fill in the last place value in my answer.
Correct. That means that in our original problem, 5/10 divides into 455 910 times. We had to momentarily change our problem by getting rid of the decimal number outside in order to do the arithmetic. Now for the next example. I want to find out how many times 5/10 will divide into 4 and 55 hundredths. As in the last example, it's not a good idea to try and divide by this decimal number. In order to get rid of it, I have to move the decimal point to the right 1 place, which turns it into the whole number 5. The rule is that if I move the decimal point in the outside number, I must move the decimal point in the other number the same amount of place values. After adjusting my problem, I can now divide. First, I have to place my decimal point in my answer directly above the decimal point in my problem, then do regular division. 5 divides into 45 9 times with no remainder. Bring down the next 5, and 5 divides into 5 evenly 1 time. The answer is 9 and 1/10. Going back to our original problem, 5/10 divides into 4 and 55 hundredths 9 and 1/10 times. Again, as in the last problem, we had to momentarily adjust the problem so that we could make our division easier in order to find the answer. How would you solve this problem, Bruno? 14 and 46 hundredths divided by 6. And remember, this can be interpreted as a fraction or a division problem. Which one would you use?
I'm not sure, Mr. Cox.
Okay, let me get you started. You want to simplify this, which means you have to do some arithmetic. This can be read as a division problem 14 and 4600ths divided by 6. Can you solve it now?
Yes, I remember how to rewrite that as a division problem. I picture tilting the fraction so that the top number slides off into the division house. So I have to find out how many times 6 divides into 14 and 4600ths. I'm dividing by a whole number, so all I have to do is place my decimal point in my answer directly above the decimal point in my problem and divide. After dividing 6 into the decimal number inside the division house, I get the answer 2 and 4100ths.
Well done. The answer to this division problem is 2 and 4100ths. Irving, how would you simplify this?
Well, I'd have to rewrite that as a division problem. 5 and 8400ths divided by 8/10. Next, because I can't divide by a decimal number, I have to move the decimal point over one place to get rid of it so I can divide. I also have to move the decimal point over one place in the number inside the division house, one place value also. First I'll place my decimal point in my answer, then divide. 8 divides into 58 and 4/10, 7 and 3/10 times. So the answer to our original problem is 7 and 3/10.
Yes. Bruno, can you simplify this problem? 64 divided by 4 thousandths.
I have to rewrite this using the division house. The 64 goes inside the division house, and the 4 thousandths goes on the outside. I can't divide by a decimal number, so I have to move the decimal point 3 places to the right to get rid of it. I also have to move the decimal point over 3 places in the other number. So I have to put the decimal point at the right of the 4, then add 3 zeros so I can move it over 3 places. Now I can divide 4 into 64,000, which equals 16,000. So 64 divided by 4 thousandths equals 16,000.
One more problem, then we'll look at some word problems. Irving, can you solve 10 divided by 6 thousandths?
Yes, I should be able to. First, rewrite it in division house form. I have to move the decimal point over 3 places in my divisor, so I also have to move my decimal point over 3 places in my other number. I wind up with 10,000 divided by 6.
Let me walk you through the rest of this, because 6 will not divide evenly into 10,000. There will be a remainder. After the first division, you can see that we'll keep repeating 6's after that. So we're going to have to decide where we're going to round off. 2 place values is always a good number unless your problem directs you otherwise. Then you round off to wherever your problem says to. Now, if I want to round this off to the hundredths place, I have to carry out my division one more place farther than the hundredths place, which would be 3 places out. That number is greater than 5, so we have to round up the number in the hundredths place to 7. So 10 divided by 6 thousandths is 1,666 and 67 hundredths. Okay, let's see if we can solve some word problems now that we know decimal division. But before we start, let me point out a few things about multiplication and division word problems. Sometimes, in certain problems, you can get an idea as to whether the problem is multiplication or division by its wording. In this problem, you'll notice that they give you the information for one thing, then ask you a question about many things. They told you 1 can of corn costs $1.29. Then they ask you to figure out the price for 5 cans. If they give you information about one thing, then ask you to solve for many things, it means multiply. You multiply by the number that changed from 1 to many. Here the number changed from 1 to 5, so you multiply by 5 to get the answer. 5 cans cost $6.45. Now look at this problem. If 5 cans of corn cost $6.45, how much would 1 can cost? You'll notice in this problem that they gave you information about 5 cans of corn, or many, and asked you a question about 1. So here they gave us information about 5 and asked us to solve for 1. You divide by the number that changed from many to 1, which was the 5. 5 divides into 6 and 45 hundredths, 1 and 29 hundredths. This is money, so that is $1.29. That's how much 1 can costs. Not all problems are like this. This is just one version of how a division problem may appear. Another common type of division problem is finding an average of several numbers. or an average of an already total number of things. For example, Ronald worked 4 days in a row and he was paid $67.60 the first day, $56.75 the second day, $86.50 the third day, and $78.30 the fourth day. What was the average amount he made per day? Here they gave us the information of how much he made for many days, which is 4. Then asked us how much he averaged per day, or for 1 day. Now the word per is the same as 1, so we have to divide by 4 here. First we have to add all the numbers together to get 289 1500ths. Next we have to divide by 4 here. This division won't go evenly after 2 places, so we have to carry it out 3 places in order to round it off to 2 places, since this is money, which always has 2 place values. Our answer is $72.29. What exactly does this number mean?
I'm not sure about that one, Mr. Slee.
Me either. Alright, let me explain what it means. Here are the actual amounts he made. Imagine trying to balance these numbers. Where would they balance? The numerical balance point is that number we found, the average, $72.29. Another way to look at this is that it would be the same as if Ronald made $72.29 each day he worked. In reality, he made lower amounts on some days and higher amounts on others, but the average would be as if he made $72.29 on each of those 4 days. Another problem that sometimes confuses people is miles per gallon types of problems. For example, Haley drove a total of 525 miles on a recent trip and she used up 30 5/10 gallons of gas. How many miles per gallon did she average on her trip? Here they gave us the information for 30 5/10 gallons of gas and asked us the question for 1 gallon of gas. Remember, per means 1. That means we have to divide by the number that changed from many to 1, which is the 30 5/10. 30 5/10 will not divide evenly into 525, so I'm going to have to carry it out 2 places so that I can round it off to the 10th place. The answer is 17 2/10. Again, what is this number and just what does it mean?
That answer is miles. The average number of miles per gallon she got on her trip.
That's correct. Now she didn't get exactly 17 2/10 miles for every gallon she used. Sometimes she got less and other times she got more. This is just an average of how much she got over the whole trip. It would be the same as if she got 17 2/10 miles for every gallon she used. Now let me put up some word problems to see if you can now solve them. Here's the first one. Lily wanted to buy some fabric to make a skirt. The fabric cost her $16.35 for 4.5 yards. How much did the fabric cost per yard? Irving, can you solve this problem?
Let me see if I can figure that one out. They gave me the information about 4.5 yards of fabric and are asking me about 1 yard. So the number that changed from many to 1 was the 4.5. So I have to divide by the 4.5 number. Next, I have to rewrite the problem and move the decimal points over 1 place to the right in each number. This number keeps repeating 3's after the second decimal place, and this is money, so I round it off to the second place value. So 1 yard of fabric costs $3.63.
Okay, now we know how much 1 yard costs. What if she wanted to buy 6 more yards? Could we figure out how much that would cost, Bruno?
Yes, we can. I have the information for 1 yard, and you're asking the question about many. So I have to multiply to find the answer. 6 times 3 63/100 is 21 78/100. Since this is money, 6 yards cost $21.78.
Here's another problem. Brandon bought 6 cans of corn and his total bill was $3.30. How much did each can cost? Irving?
I'm given the information about 6 cans, then asked the question about 1 can. So I have to divide by the number that changed from many to 1, which is 6. After placing my decimal point in my answer and dividing, I get 55/100. Since this is money, 1 can of corn costs 55 cents.
Very good. Can you now figure out how much 10 cans would cost if you now know how much 1 can costs?
Yes, you just multiply that answer by 10, which is $5.50.
I hope this decimals video has helped you to better understand decimal arithmetic and decimal numbers a little bit better. Bye. I think I'll walk the rest of the way. See you later.